Okay, so if P of 0 equals L over 4, that means that we're right here within our direction field. So what's going to happen, we're going to start with this slope. The slope is going to increase to this, and then it's going to decrease to this, and then it's going to do this. Now I think some of your graphs started out level. Okay? I'm not sure, because maybe I'm just visualizing what I saw earlier, but it certainly doesn't start out level. It starts off with a very significant slope, okay? 70 or 80% of the maximum slope, because you're already at a population where the growth rate is being negatively impacted by the number of fish you have or by the population that you have, okay? Now, if we do this, on the same graph, let's draw the curve for P of 0 equals L over 10. Well, I'm not going to, we don't want to take the time for people to actually draw this, but what's that going to look like? Where's it going to be?
Closer to 0.
Yeah. So it's going to still be going to be in the p-axis because t is 0, right? So it's going to be twice as close and then a little more. 40%. Okay? Of that distance. Well, here you can see that the slope is going to be much less. It's still going to be positive. It's not going to be 0. And if we have a direction field that goes down that far, we'll be able to see exactly what it is. But something like this, where we then go up to this and then up to this. Okay? Then we get the whole family of curves. Now, if we start with a population a little bit more than the limiting population, well, it's going to decline pretty steeply because remember, the graph changes a lot more. This graph changes a lot more between here and here than it does between here and here, right? So when we're here, that means we're really kind of like here. It means that this thing is at least twice as low as it was high here. Does that make sense? So we're going to have a pretty significant, severe negative slope here, much steeper than this one, but in the negative direction. So it means we're going to really quickly approach our limiting population. Well, that gives us a picture. If we started somewhere else, because we could say, okay, well, let's say that at some later time, the population is, let's say, here. What's going to happen? Well, it's going to go up rather rapidly and then decrease like so. But then we can also extrapolate the population function backwards. It's going to go like this and like this. It means we started with a very low population to get to this point. If this point occurred, at some later time, if this population and time was a result of a population that started at 0, it means we started with a very low population. Okay? So you can read a lot into these. Now, let's go ahead and solve the equation. The equation we get, of course, the rate of change is proportional to this, is dp dt equals k times p times L minus p, where k is your proportionality constant. Okay? So go ahead and solve this.